Hello, everyone, and welcome to this tech workshop series about security and DeFi. I'm with Patrick Collins from the team of Chainlink. I'm really happy to see you. Thank you, Patrick, for coming. Can you introduce yourself a little bit?
Yeah, absolutely. So my name is Patrick Collins. I'm a developer advocate over at Chainlink Labs. I work on building Chainlink. And yeah, what I do is do everything in my power to make engineers successful, make you guys go from building some protocols to building protocols that really shape the world in a significant way, specifically with working with oracles, data, external computation, and especially for this call, or excuse me, this video in the DeFi ecosystem. So that's my role, and I'm really excited to show you guys some really cool technical oracle and technical security first practices here.
Yeah, and today we're going to really speak about Oracle. We're going to speak about how to understand how to use it, how to working with the price data, the different DeFi exploits that you know of, and how to secure from it, and also coding the price function. So Patrick, the way we're going to do it is that I'm going to let you explain everything in the first sense. And if you have any question, you can put your question on the live chat, put the question on commentary, on Twitter as well. We're going to collect all those questions and then go back half an hour later in order to respond to all the questions in a batch. So thank you, Patrick. I'm really happy to have the Chainlink team with us on this security in DeFi. It's really a super advanced webinar of high quality that we're going to give you in order to much more for developers to understand the technology. I'm going to disappear, and Patrick, I'm letting you do your magic.
Absolutely. Well, thank you so much, David. Really excited to be here.
No problem. I'll come back for the AMA.
Awesome. Yeah. So as David was saying, the first half hour or so of this is going to be kind of me talking about some recent exploits and ways to prevent them, basically, and how we can kind of persist and move forward here. So, and then after that, we're going to go into the AMA. And really excited to go into the AMA here. So if you have questions, like David was saying, please pop them into the chat. I'm not exactly sure where this is streaming. I think it's streaming on YouTube, but if you pop your questions into the comment section there or the chat, we will get them and we will start answering them in about a half an hour. So it's on YouTube. Okay, perfect. So let me actually go ahead and share my screen real quick. Okay. Oh, looks like I need to. Can we add my share screen to the video, guys? I need admin power here. I guess we can hang out for the time being. Yeah, so I'm sharing screen. Can we add it to the? Can we add it to the screen here? Awesome. Okay, perfect. Thank you so much. So, the first thing I want to talk about is some of the exploits that's been happening, and the reason I want to talk about them is because they're really they're pretty. I don't want to say they're easy to avoid, but using Chainlink, you can protect yourselves. You can make yourselves a lot more secure, more reliable, more decentralized, and better in a whole bunch of different ways. So one of the exploits that I've seen happen a lot recently is using reserves as a pricing oracle. So what does this mean? This site actually did a pretty good job of breaking down one of the recent exploits, and in one of the contracts, there's this value of asset function. Right. And what this does is it calculates what the value of an asset is based off of liquidity pools. Right. So for those of you who aren't familiar with liquidity pools, a lot of dexes like Uniswap, for example, they use two pools to say what a price is. And that's how the swapping works. When you swap, you actually just put some collateral or put some token down in one pool, and then you take off the top of the other pool. And this is great, and arbitrageurs make it even at all times. But in an instant, if you crash one side with a flash loan or you're a whale or something like that, you can drastically kick off and imbalance the price of the reserves. And then if you use these reserves as some sort of pricing mechanism to say, okay, the price of, these two assets is X, then if somebody comes in and flash crashes it, then the balance is going to be way off. And if your protocol depends on it, well, then your protocol is going to be way off. And this is what we've seen happen a few times, actually. So if we look at a function down here, it's called value of asset. What it basically does is it gets the reserves of those pools, and then actually in Solidity, if you do like returns and you say like the name of the variable it returns, it's just going to return it. It actually just returns the value of the reserves here. So if we have this as our pricing mechanism, we can actually ruin something. So if like, for example, we have like a liquidity token or like a reward token that gets minted out based off of these reserves, we can drastically impact it. So I actually want to go through a quick demo on what's called Ethernaut. So this is a game, basically a security game, which if you haven't gone through already, you absolutely should. It does a fantastic job of like showing the weird little interactions of different protocol of Solidity and how to like make your protocols really, really secure. If you're looking for like all the like kind of low level stuff in Solidity, you'll find here. You learn about reentrancy, which is the other most popular attack that I see when people do some type of reentrancy. So if I'm not going to talk about reentrancy here, but if you want to learn about reentrancy, definitely play this game on Ethernaut, because it'll show you exactly what the issue there is. I'm going to be focusing on this DEX game, right? So in this game, we have a simulated DEX contract that we can interact with. And let me actually refresh, because I want a new game so I can show you guys how to. Oh, my computer's frozen. There we go. Okay. Let me refresh because I want to get a new instance. So I can show you guys how to do the game. So I hit get a new instance. My MetaMask is actually popping up. I'm on the RinkB chain. This is an Ethereum testnet. So I'm hitting get a new instance, and we're going to inspect the console now. Hopefully this is big enough. Where's the console? It's way down here. Oops. Sorry, I'm fumbling around down here. Come on. It's because I'm so zoomed in. I have like no idea where I am or what I'm doing. There we go. Much better. Okay, let's zoom in again. So I hit get new instance, and we created a new instance of this fake DEX. So if I hit type contract in the console down here, it says, okay, here's your truffle contract. And we can even look at what this Solidity looks like. I'm going to zoom out a little bit. But basically, this is the DEX. It has a swap function, which can swap assets. It has an add liquidity, which can add liquidity. It has a get swap price, which is what we're going to be focusing on. It has an approve function so we can approve the ERC20s, and then a balance of. So we actually start with 10 tokens of token 1 and token 2. So if we do await contract.token 1, string. Oops, sorry, yeah. This is the address of token 1. And then we can do await contract.token 2. The address of token 2. We can see the balances of these two contracts. We do contract.balance of. Second one, await string. And I made a mistake here. Whoopsies. Contract at bounce of hello. Oh, whoops. Sorry, I got to do. Balance of takes the address of the token and the address of the account. So my account is going to be my MetaMask account. So you see I start with 10 of token 1. And let's just scroll up. Or excuse me, token 2. Let's do the same thing for token 1 here. Start with 10 of token 1. So I have 10 of token 1 and 10 of token 2. And we can do contract.get swap price. And then what does this take? That swap price. Address from, address to. So we're going to grab token 1. Then we're going to grab token 2. And I think it's also amount, right? Yep, 10. So we're saying, okay, if I want to swap 10 of one token to the other token, what is the value there? Actually, let's do .toString so we don't get that weird thing. So we're saying 10. Okay, so we're saying the price of token 1 to token 2 is 1-to-1. If we want to swap 10 tokens, we swap 10 tokens for 10 of the other tokens. So they have the exact same value here, which is great. But we have an issue with that. So if I am using this get swap price based off the reserves, what happens when I tokens, address spender, you went here, second. So I'm going to approve the contract address. If you're familiar with like ERC20s, you know how we'll do token 2, which again we can grab from up here. An amount, we'll do 10. So we're swapping, we're putting down our 10 of token 1 and we're picking up 10 of token 2, and we're going to see how this affects the price. So we're going to do a wait, contract.swap. MetaMask swaps up. You guys can't see it. I'm going to go and hit confirm. The transaction has been sent. We can even take a quick look. So once this is confirmed, once we check the price now, because we've changed the liquidity, the price is going to be drastically different, right? And typically an arbitrage bot will come in, will pick it up and say, you know, I'm gonna make a profit off of this. But if your protocol bases some type of mechanism off this price, you are now going to be woefully out of sync. So now if we call that swap price right here, it's now 8, right? So we have contract.get swap price is now 8 because the liquidity pools are off, right? So imagine, and I just did it with 10. The contract itself actually starts with, I think 100 or 110 or something like that of each token. And this is simulating basically like a flash loaner coming in, crashing the price on one side and getting that drastic change, right? If you're going from the price being, 1-to-1, 10 will swap for 10 to 10 will only swap for 8. And imagine it being the other way. Let's even flip them around, and this is how hackers are actually going to get you. Now let's swap them around. Okay, well, what if I do 10 the other way? It's going to be 12. So if I want to swap token 2 for token 1, I'm actually going to get more. So what hackers will do is they'll do kind of something like this. They'll crash the price, and then they'll use whatever you're using this reserves price for to mint themselves a ton of money. So this is obviously something that I see too often. So we're going to go into the solution here in just a second. So the other one of the other issues or hacks that I've seen recently is with randomness. Actually, oops, excuse me. With randomness. So here's a contract that was actually deployed to the Ethereum mainnet, and there's one line in particular that we're going to look at. It's this line right here. So they had this function called random index. Okay, and what they wanted to do was get a random number, and that random number was going to determine, how rare their NFT was. Okay, but they have this line right here. UN index. All right, let me even zoom in a little bit. UN index equals KCAC 256 ABI dot encode packed. All this stuff, module total size. What this line does is it hashes all these parameters in an attempt to get a random number. Now, this is tough. This isn't a great way to get randomness for a couple reasons. Number one, a user can actually call this function and then just revert the transaction if they see a value here that they don't like. Okay, because again, everything that happens in the blockchain world is deterministic. So once I call this, I'll get I will get returned what basically this random number will be. And if I don't like it, I just don't send the transaction. So that was the first easy exploit. The second easy exploit here is what else could happen is actually miners could influence the block difficulty and the block timestamp here, so that if they're heavily interested in getting this NFT, all they have to do is, if they mine the winning block and it's not the block that they would have liked, they just throw it out, right? Or they change the difficulty a little bit. But basically, miners can heavily influence when you work with block.difficulty and block.timestamp. So this was a contract that did end up getting exploited. So using your randomness in this way is also a great way to not do very well. So we looked at two quick exploits here. Now I'm going to do a quick. Started the wrong place. Sorry. Now we're going to talk about the solutions, right? How do we actually prevent these attacks from happening in the future? What is going on? What did we just walk through? Let's talk about it. So the answer to a lot of these issues is using Chainlink, using a decentralized Oracle network. And, even more than that, connecting to off-chain data, financial definitive truth, APIs, prove your random numbers, etc. Right? When we look at these smart contracts, when we look at these DeFi protocols, these are these massive improvements over traditional agreements, right? Smart contracts, defeat this extreme centrality, this contract conflict of interest, enforcement, transparency, do all these wonderful, wonderful things. However, they have this issue where they can't actually, access the real world. They don't, they can't make API calls, they can't make curls or whatever. They are these walled gardens, essentially, right? And this is a big issue because if we want to get, the value of something, right? For example, when we saw with the DEX swap there, one of the token value changed it drastically when I put some liquidity into the liquidity pools. However, in real life, maybe those tokens were still just a 1-to-1 ratio. Imagine, those two tokens we worked with were DAI and USDT, right? We could have kept swapping and eventually, drained the whole contract. But in any case, learning about the real world is really tough. And the reason for this is because blockchains are deterministic by nature, right? They can't make API calls because if one node makes an API call to the real world or gets a random number, the result, that it's going to get is going to be drastically different from every single other node, right? And if they go to validate, if they go to reach a consensus, they won't be able to, right? Because they will all have disagreeing opinions on what random number is. Whereas with math or crypto-based consensus, it's a lot easier. One node can tell another node, hey, what's 1 + 1? The other node's always going to say it's 2, right? They can't go to another node and say, hey, what's a random number? Because they're never going to say the same random number. And this is obviously a major issue because we want these smart contracts to do more than just kind of be these walled garden of token transfers. So we need what's called a blockchain oracle. And a blockchain oracle is any device that interacts with the off-chain world to provide external data or computation to smart contracts, right? So these are the lens from the blockchain world to the real world. They're this bridge here, right? And they're really, really important, especially for a lot of the stuff that we're talking about here. And using an oracle to reach the real world is great, but it's actually there's more to the problem than just getting an oracle, getting one of these devices, because a single centralized oracle is actually going to become your point of failure, right? If you use a single centralized node, if you've done all this work to make your logic, to make your smart contract decentralized, and then you run all your data and computation through a single node, you've kind of just defeated the purpose of building this whole platform, this whole protocol on your decentralized blockchain, because you have the decentralized logic layer on chain, but you have a centralized logic layer, and that removes all the decentrality of your application. It also creates this massive point of failure. And in a sense, we've even seen people use like reserves as a source of a, not even as a centralized node, but just as a centralized oracle, right? Decentralized exchanges are great at being decentralized exchanges, but they're actually not decentralized oracles. They're actually centralized oracles, right? So getting your price from one DEX is equivalent to getting some piece of data from a single vendor, right? And that's why it's so crucial that we can't actually do it like that, because we're going to see more and more of those hacks. So getting your data or doing some computation or whatever through a single oracle is a great way to get hacked very quickly. So you never want to get your data through a centralized node or a single source, right? So if you have a centralized node, if you do have a centralized node and you absolutely have to use a centralized node or a centralized data piece, you need to make sure that your users are aware. You need to make sure that it's not easy to crash the price or crash your data in some sense. So but the best way, the most secure way, especially in the DeFi world, is using a decentralized oracle. So, and this is where Chainlink really shines, right? So Chainlink is a decentralized oracle network, or a DON, if you will. And it is a modular DON because anybody can spin up a node, anybody can start delivering data and really do whatever they want. And Chainlink is this network of nodes that really allow you to kind of do anything, right? So you can do you can get any input, you can get any output. You can kind of do it in layers as well. You can run a single node and have a centralized operation if you really must. Obviously, the better way is do it through a DON, do it through a network of nodes delivering data, delivering computation. But you can really do whatever you want. Chainlink is an incredibly customizable framework and a customizable network that allows you to do whatever you want to do. Now, one of the most powerful and easiest to use features of Chainlink is going to be its price feeds. And this is where a network of Chainlink nodes off-chain actually reach a consensus about the price of something and then deliver that on-chain in a single transaction. And we've seen a ton of DeFi protocols use this to stay protected and stay secure, right? So these Chainlink nodes that are off-chain are all grabbing data for some of the best exchanges and data providers on the planet, aggregating them together, delivering them on chain as a reference point for other protocols to use. So it's like this kind of pre-boxed, out of the box, like you don't have to do anything. It's already decentralized, just use it and have fun moving forward. And here's kind of a quick snapshot of what they look like here. We can see, go to data.chain.link, we can actually see some of the pairs and what they're returning. So like, for example, let's look at ETHUSD, or actually this is a Binance call. Let's look at Binance, BNB USD. We can see all the nodes that are fetching data. We can see everything about them. We can see, price history, volatility, what the oracles are doing, what each oracle is actually returning. And this is really important for understanding reputation of nodes, but we have this fantastic way of getting this decentralized reference point for data. And again, I don't really need to rehash this, but we've already seen a number of attacks from protocols getting pricing data in an insecure manner, but in DeFi especially, but using these price feeds is going to be a huge way to protect yourself. I'm going to show you guys in just a minute. But here's some of the protocols that are using these price feeds. And actually, these numbers on the bottom are a little bit out of date, but it really just shows the battle-tested prowess of these price feeds, of these data feeds. So you have Synthetics, which I think 2.2 billion is way too low right now. Synthetics is an Oracle-based derivatives platform. and creates these synthetic assets based off of their Oracle price. So Chainlink's really, really crucial there. Sushi Swap, which allows you to borrow and margin up your trades with Chainlink oracles, which is fantastic. Set Protocol, which allows you to build these fantastic strategies using real world prices. And then, of course, Aave. And again, that number is probably way too low right now, but for lending and borrowing, so you can really understand what the value of your underlying collateral is. So the protocol knows whether or not to liquidate. And you can even go to the docs and show you guys an example of how it works. We go to get the latest price feed. This is the code. This is it right here. So we have, we're importing from the Chainlink contracts package. And basically what we're going to do is we're going to create this aggregator v3 interface object, pick the price or pick the address of the contract that we want. And we can see, here are the different contract addresses of Binance. We can go to BSC mainnet. Here are all the different prices. There's a whole bunch of addresses. We can also do testnet if you guys want to test with the testnet stuff. But yeah, and then we just call this function get the price, and it returns this latest round data function. And we can actually go ahead and deploy this contract with Remix. And I've been in here a lot, so I have a number of these these Remix things on the side. Let me just find it real quick. Price Consumer v3. And this is going to be on the Coven testnet. So I'm actually going to swap over to Coven here. But I'm going to show you, how kind of quick it is to grab price information. So we're going to use injected Web3 on the Coven network here. We're going to deploy. My MetaMask popped up. You guys can't see it because of the way screen sharing works. But my MetaMask popped up, and now we have this contract deployed with this single function, get latest price, and we call it, and we see here's the latest price of ETHUSD. Now, the question is obviously going to be, okay, well, why is it so big? That's not actually what the price of Ethereum is, and it's because Ethereum and Solidity doesn't work with decimals very well. So it's actually multiplied by 1, 2, 3, 4, 5, 6, 7, 8, 10 to the 10 raised to the 8th. So we get 2,799, and boom. That's how quick. That's how simple you can use Chainlink pricing data to secure your dexes, to keep them resistant to a lot of these flash loan attacks, right? It's funny. We saw a bunch of the Aave folk actually back in November when they were happening pretty much every day. Say like, oh, we were marked safe during the flash loan attacks because we were using Chainlink oracles, which was awesome to see. Absolutely fantastic to see, this space growing and learning and adopting better security practices. So I do want to show you guys one more as well. The other big thing to think about is randomness, or really any type of service here. Like I was showing you guys before, using randomness with a hash or whatever is going to open you to attacks. It's going to open you to attack vectors. Why? Well, because like I was showing you, miners have influence, people can cancel transactions. There's all these things going on. And basically it's because blockchains are deterministic. Deterministic, by definition, means without randomness. So you can't really get actual randomness in a system that's deterministic. So Chainlink VRF is actually a service that allows you to get provably random numbers into your blockchain. So it goes out, it talks to an off-chain Chainlink node that doesn't have this deterministic issue with randomness, and that Chainlink node is going to return a verifiably random number. There's actually a contract on chain that uses a combination of key hash, its address, and a couple other pieces to verify whether or not the random number is truly provably random or not. And we've seen a whole bunch of protocols use this as well. Like Abagochis, like Ether cards. These are NFT platforms creating random traits. Also pooled together, all these different protocols that are using this to get truly random applications. And this just shows kind of the end-to-end reliability of Chainlink here and the end-to-end promise here. Chainlink is designed to do anything your smart contract can't, right? It's designed to empower your smart contract application, empower your DEX, empower your derivatives platform, empower your synthetic app, whatever it is, to go above and beyond and do whatever it needs to do, right? So Chainlink VRF is just a service. These data feeds are just a service, right? These are all these off-chain pieces that your blockchain can't the blockchain can't natively do. But as a settlement layer, the blockchain is absolutely fantastic. And so Chainlink just says, you know what, smart contract platform, you know, blockchain, we're going to elevate you guys to the next level. So you can really do anything with Chainlink here. And just kind of a few quick places where you can learn. If you're looking for inspiration, definitely check out 77 smart contract use cases enabled by Chainlink. Absolutely fantastic blog. Definitely head out over to docs.chain.link. It has literally anything and everything you could ever imagine. Developers blog is fantastic. It has tons and tons of different tutorials and walkthroughs of what you might be looking for. The Chainlink YouTube has a whole bunch of videos of us literally, you know, step by step walking through a lot of these protocols. Always, you know, once you kind of move to a production instance, you know, you want to use a smart contract development platform like Brownie, like Truffle, like Hardhat. We've got a bunch of starter kits for you. And yeah, just jump in, reach out to the community, check out some of these samples. And Discord is incredibly active, or you can always ask questions on Stack Overflow. So the other thing that I wanted to show you guys was this randomness piece here, which will show us how to get a random number. No sweat. So same thing. I've got a whole bunch of these. Got a whole bunch of these in here. But what we're going to do is we're going to deploy this contract here. We're going to call this get random number, and a Chainlink Oracle off chain is actually going to return us a random number that is provably random. So we're going to go ahead and deploy to the COVID network here. Again, this is just a test net. This is a way for us to work with our Solidity. So Binance Smart Chain obviously is EVM compatible. So you can use the Binance testnet, or you can use the Coven testnet. The Ethereum testnet doesn't really matter. But once this has been deployed, we actually have to send it some link because the oracles need to get paid in what's called Oracle gas. So when you do a transaction, you pay like a little bit of gas. When you work with an Oracle, you pay a little bit of Oracle gas. So in my MetaMask, I'm actually sending this contract some testnet link. I know you can't see my MetaMask because of how sharing works, but I am sending this contract some link, and we can even see the transaction real quick. Looks like it's indexing. So it's been included. We'll be reflecting in a short while. So we'll just go forward. But what we do now is we call this get random number function. And if I look at random result right now, it's initialized to 0. But if I call get random number, my MetaMask pops up. You guys can see it. I went ahead and confirmed. And what's going to happen is 2 transactions are going to be made. The first transaction is going to be the transaction that the Chainlink node is looking for. The Chainlink node is looking for these logs to be emitted. It sees this transaction. It sees a request has been made. So it's going to go ahead and say, okay, I got to create a random number. It's going to create a random number that is truly provably random. And then it's going to return it on chain in a second transaction. So we actually have to wait for the second transaction to happen. And now this is obviously even more advantageous that it's in this 2 transaction sense, because a user can't just brute force it, right? So a user can't just keep canceling a transaction until they see the random number that they want. It's actually highly advantageous that it's in this 2 transaction way. And it's obviously highly advantageous that it's provably random. So if we hit random result now, we see this massive number, which is random. And then we can use this to do whatever we want, right? We can take modulos of it. We can crop it down. We can get multiple random numbers out of it. We can really do whatever we want. So, and these are just kind of the 2 biggest, most popular features. But again, Chainlink is entirely customizable. And if we go over to the docs here, you can also make, any HTTP GET requests. You can modularize your Chainlink node to really be able to do any service. And more of these kind of off-chain services are coming around. So if you're interested in doing something interesting, that's going to be a little bit tougher for the smart contract platform to do by itself. Reach out, say hello, jump into the Discord, contact somebody on the team, and we'll see if we can get something spun up for you. Or again, you can build it yourself because everything is open source and you can absolutely do whatever you like. So that is it for kind of the half-hour security walkthrough here. I don't know if Jeff or David want to jump on. I don't know if I can see the chat here. I'm actually going to try to jump into the YouTube right now so I can see some of the questions here. I know David also had a couple of questions, so let me stop sharing screen here. Okay, cool. Now it's just me. Hello, hello. Oh, and David's jumping back on. Okay, cool. And I am going to grab the YouTube link if I can. Can we, hey Jeff, can we let David back in? David, you kind of come back. Or maybe not, or maybe it's just going to be me for the rest of the day. I think David, you're coming back, right? We have a little private chat here. I'm trying to figure out. First, there's a oh, awesome. Oh, there is a question on audit. Okay. So while we figure out how to get David back on the video here, I'm gonna find the video or the YouTube. Well, okay. Well, first question apparently is on audits. So let's talk a little bit about audits. Yes, absolutely. So some of the stuff that I talked about here was really, working with pricing oracles and working with, services that are insecure, right? But there's actually much more to security in your DeFi applications than just Oracle information. So audits, I would say before you even go do your audits, you're going to want to absolutely do a number of things. And actually, an OpenZeppelin member actually put out a great tweet thread about this. There's a ton of fantastic pieces you can do to make your code more readable, more understandable. And yeah, let's actually talk about some of those right now. So first of all, put comments in your code. It's going to make your life a lot easier, and it's going to make everybody else's life who tries to work with your protocol a lot easier, and it's going to make auditing a lot easier. And when you go to improve stuff, it's going to make your life a lot easier. So if you're doing some low-level assembly, if you're doing really anything, put comments in your code. Absolutely. You're 100% going to want to check out. I think Consensus and a couple of other teams have put out like security best practices or Solidity gotchas. Like that reentrancy one on OpenZeppelin that I showed you. That's probably the second most popular attack that I've seen, with the most popular attacks being, Oracle attacks and reentrancy attacks. So definitely go, make sure you understand what's happening with your Solidity. So reentrancy is really important. Integer overflow, understanding what that is. In Solidity v8, it's kind of mitigated, which is really nice. But really understand what your protocol is doing, and definitely go check out that Ethernaut game, because it's going to show you a lot of these vulnerabilities. Okay, you're really going to want to document anything and everything, because when you do go to audit, this is the first thing that they're going to look at. They're going to look at the documentation, and they're going to try to test your code. So you need code. You need code that tests your application. If you don't have tests, that's, in my mind, that's basically an automatic fail, right? Because you haven't programmatically made sure that your application is secure and free from attacks. So you absolutely 100% need to write tests. And then you also need to put some documentation in your README that says how you should actually, run those tests. So tests are really important. So, and again, the stuff that I'm talking about, you should do this way before you think about auditing. Okay. Test, please test. If you don't, if your project doesn't even compile, if somebody else doesn't even know how to compile or pass your tests, that's a really bad sign. You need to make sure that everyone can compile your code suite and test it. So please write what your abstract is or what you're trying to do with your protocol before you go audit it. Don't worry about somebody coming across your README and stealing your idea. I promise you, Everyone thinks they got the golden goose. The ideas are kind of a dime a dozen. So please, 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 like, make sure that whoever's working with you to audit, or even yourselves, like, you have everything written down, because it's going to make your life a lot easier. It's going to make auditors' lives a lot easier. And I promise no one's going to steal your application, right? The only applications that are stolen are the ones that are, already have billions of dollars locked in and already established, right? Because nobody wants to take a chance on somebody else's random idea. So there's a 99% chance you're going to be fine, and nobody's going to steal your idea. You want to have an open comms channel. You can absolutely be anonymous, which is great, but you're going to want to be able to talk to people, right? You're going to want to be able to say, here's why I did X, or here's why I did Y. Auditing isn't really like, what auditors are doing is they're literally, walking through your code line by line, looking for issues, and they need to understand what you're trying to do, so that they go, hey, I understand you're trying to do this, but your code's actually going to do this. If they don't understand what you're trying to do, then an audit isn't really going to be helpful, right? Because maybe they go, maybe they wanted to do it like this. Maybe this is why they wanted to, they wanted to get flash attacked, right? Maybe some protocol does. I don't know. So be open, document your code, make your code very readable. You really just clean everything up. If you want to look for best practices, compare your code to some stuff on OpenZeppelin, compare your code to stuff on Uniswap, compare your code to the Chainlink core, Compound, Aave. Check out these protocols that have really, really done well, and see, okay, how are they creating their application? How are they designing their repo? How are they doing everything right? And kind of keep with whatever syntax that they're doing. There's no reason to reinvent the wheel. So you can kind of use some of these standards that they're using, right? And especially with standards like the ERC20, like NFTs, like proxy contracts, there's a whole bunch of standards that have already been created, and there's no need for you to kind of recode in ERC20, right? I'm a big fan of using OpenZeppelin packages. So if you head over to OpenZeppelin, head over to their contracts, you can actually copy and paste the contracts into your own protocol.
Hey.
Hey, welcome.
Yeah, we're back.
We're back. Okay, cool.
I let you finish on this. It was exactly the question we had. It was how to do the audit, what to do for the auditor to his work, what is the step, and when to do the audit precisely, before mainnet, after mainnet, during the deployment. What is your advice on this?
Sorry, what was the question?
When is the best time to really audit? Before going to mainnet, after going to mainnet, while you're deploying, or just before deploying, just after deploying? What is your opinion on that? I think it has been done in gradual stage.
Yeah, great question. So think of audits as a code review with an emphasis on security. And you really should never be pushing anything to production without a code review. So you can think of mainnet as production, right? And if you have a protocol where you're going to be securing money in it, you need to audit before you go live. If you go live and then you get an audit, well, if the auditor goes, hey, you got a huge bug here, well, that means that entire time that they were auditing, somebody, you were potentially exploitable. So I have heard some people say, oh, well, my protocol is not going to have any money. It's not going to have this and that. If that's the case, sure. I mean, I've deployed stuff to mainnet that's like $1, right? And if it's super, super low value, then sure, maybe you could skip the skip the $20,000 audit, or however much it is, and that's another question we get a lot, is what's the price? It can really range on who you're getting the audit from, what they're offering. I've seen 5,000 to 60,000, anywhere in that range. It probably can go even wider than that. It really depends on your protocol and what you're doing. So definitely want to audit before going live. You absolutely need to audit. But the audits aren't even a catch-all, right? If your protocol breaks, don't go to the auditors and say, you guys messed up. Because like I said, audits are really
audited, but you have audited. Yes, we have audited, but it doesn't prevent flaws. It prevents generic flaws. An audit is like a technical control of a car. It doesn't prevent any accident or any losing part. It prevents the main one, the general one.
Yeah, exactly. So you really need to do your due diligence before you go audit, right? And the easier you can make the auditors' lives, the better your audit is going to be. Like something that I see a lot, and this is something that's really, really frustrating, is when a protocol wants to be crazy secretive about their roadmap, what they're looking to do, and what their IP is and whatever. And it's just going to mean the auditors are going to catch less things, and that's clearly not something that we want. So please, be open, be helpful to the auditors, so that you can help your own protocol. And then also don't put unrealistic expectations on them. They are literally for months going to inch by inch, go through all of your code, and they want to make sure they get it right. So please don't rush them. And definitely go audit before mainnet. And if you do go mainnet after an audit, if you want to change something, get that audited too. I don't care how small it is. I saw a protocol change 4 lines of code after audit. So they got an audit, they changed 4 lines of code, then they pushed to mainnet, and it was that 4 line of code change that got them hacked. They said, "Oh, it's a small change, it's whatever." That's what'll get you. So get audits, get code reviews.
Yeah, an audit is a seal of approval, meaning that once you open the letter and you change it, you have to have a new seal of approval. It doesn't. It's really important, meaning that and that's also for the developer and the technical people to understand that, is that also like the audit of a version 1 of one software doesn't give any guarantee about the version 2 or the future version whatsoever. So each audit for each version and each things. One about that, we speak about update. So if you do a mistake, is there a way for you to change it easily on the smart contract or inside this contract, how you deploy it, etc.? I think it's also about the migration from non-Oracle to Oracle, how easy it is to do.
Yeah, so this is actually a really good question. What the topic that you're actually kind of getting into is upgrading your smart contract version to version. Now, it depends on how you've implemented it. If you've implemented it kind of the traditional sense, where you haven't programmed any like upgradability or modularity into your protocol, you do have to kind of manually take all your storage from your smart contract and move it to kind of a new one. Basically, you basically have to redeploy, with all the storage of your last contract. Now, there are a number of different tips to make this a lot easier. One of them being, if you're doing any type of mapping, you always want to omit an event whenever you do a map, because arrays are really easy to move to a new protocol. Mappings are not, because as you know, every single key is a key in a mapping. So you want to omit an event every single time you put some storage into a mapping. But yeah, so the kind of the hardest way to upgrade is to, I call it the social yeet, but basically it's when you say, hey, this old contract is no longer the contract. This new one that we deployed, this is the right one. And by social convention, people adopt that new contract and say, okay, we'll use this one over here, right? And that can be kind of a very long, tedious process, but sometimes it's important to do. It's also one of the most decentralized ways to create a protocol, because making your protocol really hard to be upgraded means that nobody kind of has authority and just kind of quickly changing stuff. So there's pros and cons there.
And now, we saw that kind of deployment. It worked well. Developers doesn't have to be afraid about doing things the user base follows. We saw that with yield optimizing, such as auto farms that have done a migration, Pancake Bunny as well. Like when you work and when you scale, at some point you need to update, and that's normal.
Well, it actually depends. So this could get into a philosophical debate. Actually, some protocols will argue, once my DEX is deployed, that's what it's going to be.
It's perfect.
But, well, it's probably not perfect, but it's they're saying, hey, there's a reason why it doesn't have the authority for anybody to go ahead and change it, right? Because the code is going to work exactly as it does for all of eternity, right? So maybe it works perfectly, but as we've seen, we've seen Uniswap v3, Aave v2, all these like V updates is when a protocol basically, deploys a new version of their contract, and they say, hey, go use this new one, right? This is the latest and greatest. But yeah, and you have to migrate stuff over, or maybe you don't. Maybe you want them to be totally separate. It's really up to what you want to do. But
you can stay to V1 and continue your life if you want. But
also a lot of protocols will use a proxy actually, so that they don't have to do kind of this difficult migration. And the migration is a lot easier now. To use a proxy and create like contracts that can be upgraded programmatically. There does have to be some sort of basically admin key. There is some type of admin that can do these upgrades. What some protocols will do is they'll have a governance protocol control the admin key and control whether or not they want to upgrade to some new contract or not. But that's the other way to implement it. I actually wrote a blog recently on doing upgrades. OpenZeppelin had some great tutorials on doing them. I'm coming out with a couple different videos actually on doing them, but that's the other way to do it, or to think about it, is to have a proxy, have it upgrade to a new implementation. But actually, a couple auditors, TrailBits being one, actually wrote some interesting things about it. They said they actually don't recommend people building these proxies, people building these upgradable smart contracts, because then they get lazy. They go, oh, okay, I can just upgrade if I screw up, so I'll just send it, and if I screw up, I'll upgrade it later. But you really want to take the time. You really want to do the due diligence to make sure your original implementation is solid and it does what you've intended it to do. But like you were saying, David, a lot of protocols, they're going to want to upgrade. They're going to want to do new stuff. So using a proxy, an upgradable smart contract using a proxy is a really good way to do that too. Just make sure you really understand what's going on with your delegate calls, with your calls, and you get a really, really good audit. And the other thing to keep in mind is that your users will know that you hold the admin key, so they'll know that it's not
prevent, tell everyone, prevent in advance, because it's important, because you're gonna have media cryptos that's gonna fall under you in the last in the before 1 minute to the next 5 minutes when you speak about that. It's really important that all the community is prepared when you do an update, because otherwise it could mislead. It could be seen as a BSC exploit or as an exploit inside any smart chain, and any chain. So it's important when you work in decentralized way to be transparent also by the developments that you're going to do, but the announcements that you're going to do, Telegram communities that you already have, etc., need to be prepared. Last question, which is a little bit like a Joe average question, is like, let's say I'm a developer, I'm inside the street and I'm looking at some smart contract, etc., and I spot a bug, I spot a flaw, I spot a vulnerability inside one smart contract. I don't want to exploit it. I'm a good Samaritan, as we say in French. What do I do? Who to contact? Who to say something? Because it's a running out of time when we look at those things. What do I do in order to not maybe impact the project but to protect it? Do I leave it open? Do I say it on the net, or do I contact someone in particular?
Yeah, this is a really, really good question. And there's definitely a lot of etiquette around finding a hack, finding a vulnerability. So what you're referring to basically is what's called white hat hacking. So you find a vulnerability and you do say, okay, I'm not going to exploit this because, I don't want this protocol to, hit the fan. So there's a couple different ways to go about it. Number one, don't post publicly about it. Like, do not post publicly. Don't go on Reddit and say, oh, I found this vulnerability. Don't do that, because that's somebody's going to see that and hack it. What you really want to do is you really want to find some type of communication channel with these users, with the protocol, and even potentially somebody's security inclined, right? So find somebody who's really, really, who works on this stuff in the space, send them a DM with the protocol, show them, hey, here's where I think the vulnerability is, send them the block of code. I mean, especially if it's randomness related, or if it's reserves or price related, you can even put me on there, because I can tell, like that, if there's a vulnerability, or somebody from Chainlink, or excuse me, somebody from Chainlink Labs, if it's some other type of vulnerability, get in communication with that protocol ASAP, right? Because that is something that, okay, if it's out there and people could lose a lot of money, that's something you're going to need to migrate to a new version very, very quickly. Or what a lot of protocols will end up doing is they'll exploit it themselves, kind of like really silently and quickly deploy the new version of the contract and then move everyone's stuff over to that new contract, right? But yeah, the worst thing you can do is publicly post about it. Best thing you can do is you get into a communication channel with that team. Hopefully they have some way of contacting them with urgent issues, but that is the best practice there. And then come up with a war room and a way to migrate to a new version, or a way to fix the bug.
Let me give some concrete ways on my community experience, etc. So don't post inside Bitcoin Talk or any stuff like that. It's not going to be valuable. But every project have Telegram channel, for example. You can ask to an admin on those Telegram channel to be contacted by a security team in order to speak about the problem. Don't publicly tell it's about this, that, there, or this. Like, keep it secret for two reasons. The first one is that you don't want the project to be exploited. The second one is quite fun, and all of you knows there is bounty hunter program sometimes, and when you find this kind of vulnerability, but they could be a reward for you because you securize the system. So it's also a kind of benefit for you also to like keep it directly to the team and to go first to the team to speak with them, etc. And as you say, you can directly contact Patrick or even Chainlink when it's about randomness or like things that is inside their job, because they're gonna be interested to contact the team to say, hey, you have a problem there. We can solve it this way as well by using our protocol, and it's gonna be a win-win for everyone. So thank you, Patrick. Do you have any other elements that you want to add to us, or anything that that you want to know?
Yeah, just kind of a quick wrap up here. Solidity, smart contracts, we are going west, right? There's a lot of uncharted territory here. There's a lot of gotchas, but if you go about your day in a very security mindseted manner, we can build fantastically powerful, fantastic protocols that really shape the world. So don't let this stop you. Don't let these security things stop you from going and trying stuff. But when you go, do take that next step. Make absolutely sure you do your due diligence in understanding, okay, what could really go wrong with my protocol and what can happen. So ideally, especially when it comes to pricing, randomness, any type of service, anything that a smart contract has a hard time doing, definitely make sure you say, okay, like it doesn't make sense to put Chainlink in here, because if it does, you're going to save yourself a lot of headache and probably a lot of money.
Okay, thank you. We're going to end this stream now. Jeff, please, thank you. And can you end this stream? Patrick, I thank you a lot for this opportunity to be with the Chainlink team. You're one of the teams that I appreciate the most, and one of the crypto projects that I appreciate the most. Tomorrow, 12:30 p.m. UTC, we're going to speak about the final security take. And what we're going to do is speak about proactive action that you can take in order to securize inside the blockchain ecosystem. Thank you, everyone, to have joined. And we'll see you tomorrow on the next workshop. Jeff, can you plug it off? Thank you. Bye-bye.
Thanks so much, everybody.